Okay, in this video, we are going to compute these limits, and in fact, they are really easy because we have our secret weapon, namely the list. So, recall that as x is approaching infinity, well, the Ln(x) is the smallest one, and the next one is x to the p's power, where p is a positive number, and then the next one is b to the x power, where b is greater than 1, and lastly, we have x to the x power. Well, how are we going to use the list? Let me show you. First of all, look at this first one. The limit as x approaching infinity of square root of x over e to the x. This right here is saying x to the 1/2 power, isn't it? Yes. And that's right here, x to the 1/2 power. This is so small compared to the exponential. We have the e to the x. So that's right here, b to the x. b is greater than 1, right? So e is 2.7, so that fits. Well, the answer to this right here is just because the top is so much smaller than this, if you take x is approaching infinity, the whole thing is just going to be 0. The top is so small, if you do the ratio, it will be 0. That's it. Next, we have x squared over ln(x). Well, x squared belongs to here, natural log of x is right here. X squared is much bigger, so big over a small thing right here. In this case, we'll get infinity. That's how we use the list. This right here, the reason we put down less than is because if we divide, if the top one is smaller than the bottom, well, we get 0. If the top one is bigger than the bottom, then we get infinity. So that's the idea. Next one, 2 to the x over x to the 200th power. Well, the answer to this right here, even though x to the 200th power looks really powerful, but it's not. No, 2 to the x is much better. This right here, the whole thing will end up to be infinity because again, 2 to the x belong here, and that's bigger than x to the 200th power. Much, much bigger. Yeah. Lastly, we have natural log of x over 1.5 to the x power. So we're comparing this over that. Small over big. And in this case, you get 0. So that's it.